In this problem, it says the ratio of the number of students in the first class to the number of students in the second class is 4 to 5. If n students move from the second class to the first class, the ratio is reversed. If there are a whole number of students in each class and the total number of students is less than 100, determine the sum of all possible values of n. Okay, so let's assume at the start that there's just 4 and 5 students. Now what happens? Well, in order for that to switch, the ratio would have to become 5 to 4. So how many students from the second class would have to move to the first? That would be 1. So now, keeping with the 4 to 5 ratio, what if there were 8 and 10? Well, then the ratio would have to flip to 10 to 8. And how many students would have to move then? N equals 2. If I do this again, and now it's 12 and 15. If I want to flip the ratio and make it 15 to 12, that means 3 have to move. Now, there's a pattern going on here, and that basically we take the ratio of 4 to 5 and whatever we multiply it by, that's how many students move. So here, this is the ratio of 4 to 5 times 2, top and bottom, so that means n equals 2. Here it's 12 to 15, n equals 3. Now we could keep going. 16 over 20 becomes 20 over 16, n equals 4. But the question is, how long will this stop? How long until it stops? Well, here's our restriction. It says that there's a whole number of students in each class and the total number of students is less than 100. So the easy way to figure this out is they're in a ratio of 4 to 5. So I'm going to take, so if we were to combine them, the number has to be a multiple of 9. So if I take 100 and divide by 9, that gives me 11.1. So what that means is that the biggest we could get is 44 over 55, which would switch to 55 over 44, but this is still less than 100. So all the values of n could be anywhere from 1 up to 11. So if we add those up, we get, 1 plus 2 plus 3, 4, 5, 6, 7, 8, 9, 10, 11. We get a total of 66. Those are all the values of n that could work. And there's our answer, and we're done.